Hello, I would like to do review part 4, number 2. Um, so this is in your books on page 402, and as always, a good idea is to do the problem before you watch me do it. So now this problem in your book is basically some workers, and it's company's human resource officer, and they report a breakdown of employees by job type and by gender. And then over here, they give you a table, and then they ask some questions. So before I ever get started on a problem, I read through my questions. So we're going to need to answer the probability that a randomly selected worker is female, female production worker, female if the person works in production, production worker if the person's female, and does the data suggest that job type is independent of gender, and then explain. So when they already give me a table, looking at the questions, it seems reasonable that I would want to use a contingency table. So let's start out by making a contingency table. So on the left-hand side, I'm just going to have management, supervision, and then production. And then along the top, I'll have male and female. Alright, and then we just kind of fill in our numbers. And here I have 7, 8, 45, and of course the nice thing about a contingency table is putting in your marginals, which will help you with your probabilities, because we know that probability is just success over total, so that'll give us our total. So for females we have 6, 12, 72, that has a marginal of 90. And then of course we would want to do our row totals as well. So we get 13, 20, and then 117. And hopefully, if I've added everything correctly, which I don't always count on, tally up your column and then the bottom row, and hopefully they both equal the same number, which in this case is 150. So going to our questions, we have number 1A, and we'll start with letter I. And the question is, what's the probability that our randomly selected person or worker is female? So just looking at the probability of female. Well, now that I'm a contingency table, it makes it super easy, because I'm just looking at number of female, which is 90, out of total number of workers, which is 150, which, doing that quickly, is 0.6. And of course, I can express it as a fraction, a decimal, or sometimes when we're writing these as sentences, it makes it nice to put it as percent. Next one, number 2. So this one is asking what's the probability that a worker selected at random is female or a production worker. So you can write this out in words, or you can use symbols. Of course, as mathematicians, we love to use symbols because it saves us from a lot of writing. And so I'm going to do female or production worker, kind of use that symbol just to save myself. Now, here, if I do production worker, so probability of production worker, that would be looking at this row, or female. Notice that this number 72 gets counted twice, so we need to make sure that if I'm saying, well, I have 117, I'm going to put this all over the same denominator, because adding or subtracting, same denominator, are production workers. I have 90 that are female. However, of those, I've counted the 72 twice, so I need to actually subtract that out. So I'm going to subtract 72, because that kind of went in there twice. See how the highlighted is out twice? And if I put that in my calculator, I get 0.9. Question 1A3 asks us, what's the probability that a randomly selected person is female if the person works in production? So now I'm just looking at production, okay? So here I'm just looking at the production, so in total I'm looking at that one row. So this is what we call a conditional. So my condition is that they are in production. And I want to know the probability that I select a female out of those in production. So now my total is just the 117, because there's only 117 in production. Of those, 72 are female. When you do that, you get 0.615. Now, if you want to use the formula, which is on your glossies, which you can do that, we know that a conditional, and I'm just going to abbreviate here, female given production, is looking at the probability of being female and production over the probability of those that are in production. You're going to get the exact same number, okay? But it is a formula in your glossies that you can use. All right, going to number 4 in this same area, says what's the probability that I select a production worker if I know the person's female? So this is the flip of the other one. So I'm looking at the probability, given that I'm just looking at females. What's the probability that I select a production worker? So now I'm looking at this column here. So my total is now 90, because I'm only looking at the females, and the probability that I'm a production worker is 72. So 72 out of your 90 is 0.8. Alright, so that was all 1A. Going to 2B, that is. This is 2, not 1. Going to 2B, it says, do these data suggest that job type is independent of gender? Well, we have to recall that we can't just comment on it as of our thoughts. We need to prove everything with statistics, direct reference to stats. So 2 ways that we could show this is we could show that the intersection of female and production worker is equal to the probability of female times the probability of production worker. Remember, that's one way. That's the one I always think is the easiest. Unless we've already calculated out some conditionals, which we have. So we could look at the probability of being female given a production worker and see if that's equal to the probability of being female. Now, we've already calculated both those numbers out. So if we look back at things that we've already done, we've already looked at the probability of being female, and we already have the probability of female given production worker. So since we've worked those out, we can just write out our answer now. And those are super close. They're different numbers, so I've got 1.5% off. So they could be just due to sampling error, or there could be an association there. So in this case, just to be on the safe side, I'm going to say that the data suggests that there may be an association. Oops. The whole thinking and writing at the same time. That there may be an association. Between, let's look back at the question here, independent of gender, and we're going to use production and female. So between a production position and gender. And then we could say we had 60% of the workers were female. Whereas 61.5% of production workers were female. Okay. So we could, I mean, it's close. It might be helpful somehow to kind of check some other numbers. So looking at the males and then males given so males given production and probability of males, just to see if those are close. Okay. But I would probably end, however, this is such a small difference and it may be due to sampling error. And I would just kind of write that on the end. However, this is a small difference. And maybe due to sampling error. Now, 1.5% is small. I probably wouldn't go any bigger than that as far as saying that it might be due to sampling error, but I mean, this 60% to 61.5%. Anyhow, that's number 2 on your Unit 4 review.